Hi, welcome to the Calculus 3 lecture series. And we are in the unit partial derivatives. And this is our video number 5, the partial derivative. We're going to talk about the chain rule. And also we're going to cover how do we use the partial derivatives and try to do the implicit differentiation, make the implicit differentiation is a little easier than what we learned in the calculus 1 here. Okay, so let's go ahead and start. And this one is a pretty easy concept about the chain rules here, okay? So now let's go ahead and start. Okay, so for the chain rules here, okay, so the first things here, we know we have two situations. We call this a case number 1 and the case number 2 here. But in general, they have the same idea. So that means both, okay, so let's say the both x and y, they are a differentiable function of t here. That means x is a function of the t and y is a function of the t. So then if you substitute the z and the x and y into this function, so what I know about here? So I know z is going to be a function of what? A function of the t's, right? So that means the x is equal to a function of the t and the y is equal to the function of the t. So when you substitute to the z equal to the function of f of x, y, then the z is a function of the t. So now what is the, what is the z take the derivative of the t? So the only things here we need to be a little bit careful is about the notations here, all right? So here I said dz dt. The reason why I say it's dz dt, because the z is only a function of the t. And then we use because both x and y can be the function of the t, so that's why we use the partial derivative concept. So look here. So the partial derivative, that's why I use the rows here, right? So I said is equal to the partial derivative of the z to the x, but the x is a function of the t, so but the x is only a function of the t, so that's why I use dx dt. So the same here, okay, because after you take the derivative of x, you need to take the partial derivative of the y's, right? Then the y's here, right? So dy dt, this is the chain rules, right? So this is the chain rule because the y is a function of the t. Because y is only a function of the t, so I use d instead of the row. So this notation is here, right? That means this is a partial derivative. That means if your function have more than one variables here. Okay, so now let's take a look at the case number 2 here. The case number 2, instead of x is a function of the t, so we say, hey, x is a function of the two variables, st's here. Then y is a function of the st. So when you substitute the z equal to the f of x, y, so z is a function of the two variables. So now if I want to find the partial derivatives here, right? So look here, so you want to find the partial derivative of the z respect to the s and t. So that's why you say rho z, rho s, right? So the rho z, rho x, because x is a partial for z, so it's rho z, rho x. Then because the x here is a function of the st, so you say rho x, rho s, right? So it's all partial derivatives here, okay? So then this part is what is the chain rules, right? This part is what is the chain rules here. So the concept is pretty easy. Okay, so now let's take a look at the problem number 1 here. So let's say dz dt. Okay, so let's see here. I want to find the dz dt. Of course, what you can do, you can plug in the x into the x squared, y to the equal to t squared equal to the y. Then you change everything to t first. Then you can take the derivative. Or you can use the chain rule, right? So we say the first thing here, you take the derivative, a partial derivative to the x. So what is the partial derivative to the x here? This is 2xy, right? So this is a partial for x. Then you need to the chain rule to the derivative of x to the t. So what is here? This is et, right? And then plus the partial for what? Partial for y. So the partial for y will just be x squared. And then the derivative for the y, this is the chain rules here, right? So what is here is 2t's here. Okay, so now after you finish, then you can, because we find the derivative of dz dt, so if you like, you can substitute to the all this. So this is 2 the et, and y is t squared, and the et plus x squared, so it's et squared times 2t, all right? Then if you want, you can simplify a little bit. So this one will be equal to 2 the t squared e2t's, right? So the first term, then plus 2t and e2t also, all right? Okay, so 2t and, okay, so here, I need to better write a data better here. So here, my eraser, so here, okay, so this one will be 2t e 2t. If you like, you can even simplify a little more. So factor the t and the 2et out. So this is 2t. Now you can even factor 2 out, right? So if you factor the 2 out. So if you factor the 2 out, right? So here you will have what? T plus 1 here. Okay, so this one is pretty easy, as long as you know how to do the derivatives, right? So now the next one here, I want to find the rho w, rho u. So w is x, y, z, and x and y and z, they're both of the function v and u. Okay, so let's see here, rho w, rho u here. So the first, I need to do the partial for x, right? So the partial for x, this will be the 2x, y, z. Right, so this is a partial for x. Then the chain rule for x, take the u. So what is here is v, right? Okay, then plus the partial for y. So y, you take the derivative, will just be 1. So x squared z. Then the chain rule for the dy, rho y, rho u. So what is here is a sine v, right? Okay, now the last one here is a partial for z. So what you have here is x squared y, right? Okay, x squared y. Then, you know, you need to do the chain rule for z. So the z's here, it will be v cosine u here, right? Because the derivative of the, you know, the cosine u. Okay, now they want to find at uv equal to pi over 2. So when the u and the v add the pi over 2 over pi over 2, you substitute, and then I can get the x here is uv's, right? So it's a pi square over 4. Then y is equal to the u and the sine v. So it's pi over 2 because the sine 90 degrees is 1. And then z is equal to v sine u. So sine u at 90 is 1. And so this one's here will be pi over 2 here. Okay, now you substitute all this value to the rho w, rho u, with a pi over 2 and the pi over 2. And then the final answer, you just substitute all the values. So this will be 3 over 32 to the pi to the 5th here. Okay. All right. So this is the partial derivative, and this is the chain rules, right? So it's pretty simple here. So every time you take a partial derivative of your variable, and don't forget, so like all these are the chain rules, right? So like this is the chain rule, this is the chain rule, this is the chain rule. So you just be very careful and be patient, and you will get it. Okay, so the next things here, we're going to take a look, how do we do the implicit differentiation? So what we learned in the what we learn in the calculus 1, so we say, hey, when you the implicit differentiation we learned in calculus 1, we said, hey, let's just try to take the y prime, and every time, take the derivative of the y, because y is the function of x. So don't forget to take off the y primes here. So for these problems here, so I'm going to show you what I mean this formula. But let's use the part A as the review, what we did for the, in the calculus 1 here, right? So in the calculus 1, we say, okay, so how do I find implicit differentiation? Okay, I do take derivative here. So this is 6x to the what? Square, then plus. Okay, so here you say, okay, I have 3x, and also I have y's, right? And because y is a function of x, so I said, okay, I need to use the product rule. So I'm holding the first one, so take the derivative of the second one. So y, take the derivative is 1, but every time you take y, don't forget you need to take a y prime. Then you hold the second one, you take the derivative of the first one, so it's 3y. Okay, then plus, so you take the derivative of this one is ay, but also what you need to do, don't forget y primes here, right? So then this is equal to what? This is equal to 0 here. Then the next things here, you say, hey, I'm combining the y primes here, right? Okay, so you are combining the y prime, so this is 3x plus ay, the y prime. Then you move all the other to the other side. So this is 6x squared minus 3y, right? So how do you find the y prime? And you divide this, right? So this is how do you find the y prime? Okay, so this is ay, and this is put a negative signs here. So this is x squared plus 3y. This is the method we used, right, when we were in the Calc 1. Okay, so this is what we did in the Calc 1 here. Okay, and then in here, so what is this one? They said, okay, so like if in here we can use a partial derivative concept. So it says here, you treat all this as a big f of xy function. So what do they say here? So they say, okay, so you move the 7 to the other side, so you will have f of xy is equal to 2x cubed plus 3xy plus 4y squared minus 7 equal to 0. Then this formula say, hey, you just take the partial for x and the partial for y. Okay, so that's very easy. So I don't need to worry about the product rule or like some chain rule later. So I say, okay, here the f of x, just take the derivative, the partial for x. So this is 6x squared. And then here, this is 3y. That's it, right? Because all the the remaining is y, is a constant. Then I take the f of y here. That means I treat x as a constant. So what is y here? So this is 3x, then plus what? ay, right? So now, according to this formula tell you, hey, it will be the negative f of x over f of y here. So what is my y primes here? So my y prime, okay, so let's use the same color. So the y primes here will just be f of x. So this is 6x squared plus 3y and 3x plus ay. Then you put a negative sign. That's what is this formula tell you. It's a lot easier, and also the chance to make an error is less here. Okay, so now I'm going to show you. So the same way, if you have in the R3, so like if z is a function, if z is a function of f of x, y, so how do you find rho z, rho x, and how do you find the rho z, rho y? You can do the same things here. So let me So let me show you why this is true, okay? So, you know, why we talk this implicit differentiation in this like a partial derivative. So here, this is y, we said y is, this is in our truth, right? Okay, so this is, in the calculus 1. So then we say we combined it. So we say f of x is here, right? Then the y, and we say this one equal to 0. So basically, we can say this is f of x, y is what? Y is a little function of x, right? Equal to 0. And then we said I'm going to take the partial derivatives, right? So because the big F have a function of x, so I will say the first one, I will say rho f rho x here, right? So rho f rho x, I'm taking the derivative for the first ones here. So this one is then you times the partial, the chain rules, right? So this will be the dx dx. Then plus, because rho f what? Rho f rho y. And what is y is here? Y is what? Then I said dy dx, right, equal to 0 here, because here, remember, this is what? This is the chain rule concept, okay? And then we know the dx dx is equal to 1, right? Okay, so now I have rho f rho x plus rho f rho y and dy dx equal to 0. So rho f rho x, I can use this notation, plus f of the y, dy dx, I can use y prime if we want, equal to 0. That's why we got y prime equal to the f of y, right? So f of the y and the f of the x for the negative signs here. All right. Okay, so the same ways here in R3s, right? So let's see here. So in R3 here, right? So I have a f of, so in here, okay, so we have a function like is z is equal to the f of xy. So it's two variable. So now I can change this one to a capital F of xy and z equal to zeros, right? So if you want to, so basically this is just a capital XY and this is little xy because z is a function of xyz. Okay, so now let's use the partial again. So the rho f, rho x, right? So if I want to find the x here, so the rho f, rho x is here. Now, because the x, right, so now I can say here, this is rho x, and the plus, right, so the rho f, rho y, the partial to the y, then y, I need to take the derivative of x, so this is rho y, rho x here, then plus rho f, rho z here, right? And here we say it's rho z, rho x here is equal to zeros here. Okay, so all the same here, right? So these terms here, rho x equal to 1. And then the rho x, because f and x, they both are the independent variable, input variable. So rho y, rho x is equal to what? Is equal to zeros, right? Okay, so now I can rewrite this and then get our final equations. Okay, so now I can rewrite this. Okay, so now the rho f, rho x, right? So here we have a rho f, rho x, and the whole middle term disappear, plus rho f, rho z, and the rho z, rho x equal to what? Equal to zeros, right? So then this one I can write as f of x. What is this one's here? I can write like f of what? F of z here, right? Okay, so now finally you get the rho z, rho x, right? So it will be equal to what? F of the z, f of the x have a negative signs, right? So the same way you can get rho z, rho y is equal to the negative of f of y and f of z here. Okay, so that is what is the this equations try to show you here. Okay, so it's an easy way to do the implicit differentiations here. Okay, so now let's take a look at these ones here, the part B is here, right? So let's try to use our things we just learned how to do the, the differential equation, use the partial derivative, take a look at the implicit differentiations here, see how easy that is. So let's say my f of xy is here, right? So it's equal to what? X squared y cubed plus cosine xy equal to 0. Okay, so now I just take the partial is f of x. I don't need to worry about the product rule, those things. So I'm just taking the derivative of x and then I treat y as constant. So this is 2xy cubed, right? And then the cosine xy, so it's a negative sine xy. Okay, and then you take a look at the chain rule xy, so it's times y here, right? Okay, now I do the same way, f of y, so it will be 3x squared y squared, then minus the sine xy, because cosine is, then the chain rule for y is x here, right? Now you can find your y prime is pretty simple, right? It's just a negative f of x, put a negative sign in front, then put whatever you have in the f of x, the partial derivative. So this is y sine xy. And then this is 3x squared y squared minus x sine xy. Right? So be careful, this negative is for all of them, right? So it's pretty simple. Okay, so now let's take a look at the other ones here for rho z, rho x, and rho y. So now I have, okay, so now my first things here you need to do, you change it to your f of x, y, z, just in case in here that your right hand side is 100, it doesn't make a difference. Just in case if it does have some function, you need to move everything over. So xy, xz plus e to yz minus 100 equal to 0. All right. So now we can just do a partial of x. That means I treat everything as x, right? So this ones here will be y to the exy, because you take the derivative of x and then the chain rule for the xy. And then here we got another one. So this is z to the xz. All right. And the remaining is 0 because I'm taking the x. Now the y here, this will be e to the xy. This term equal to 0. Then plus z to the eyz. Right? Then I have f of the z, the partial for z. First term disappear. The second term will be x e to the xz and the plus y e to the yz, right? So it's pretty straightforward. Okay, now I want to find the rho z, rho x here. So if you want to find the rho z, rho x, it will just be what? It will just be the negative f of x, f of the z's, right? So you have a negative sign in front. So f of the z is x e to xz plus y to e to yz. Then what is f of x? F of x is y to e to the xy plus z to the e to the xz's, right? So the same things here is rho z, rho y's here. So the rho z, rho y will be negative f of y, f of the z. So still the same, you put the rho z on the denominator, xe the xz plus y to e to yz. Then the top is partial for f of y. So this is x e to xy plus z to eyz. All right. So it's a lot easier, if you use what we learned in the Calc 1, you still can get it. But then when you talk about xz, you need to worry about the product rule, those things. All right. Okay. So now let's try to do the last province here. So the last province here is, they said, find the equation of the tangent plane at the point at the 2, 1, 1. So I know in order to get the tangent planes here, right? So what is the tangent plane we have here? So that means we need to have the f of x, the partial for x, the partial for y, and then, so this is what is our tangent plane formula, right? So we say it's z minus z0, then this is f of x, x0, y0, then the x minus x0, then plus f of the y, x0, y0, then we have y minus y0s, right? Okay, so so now we find, so what do we need to do here? We need to find the partials here, right? So let's try to do it. Okay, so the partials here. So we can use what we just learned here, because otherwise I need to use the implicit differentiations, right? Okay, I can say x, y, z is here, move everything. So this is x squared plus 2y squared plus z squared minus 6 equal to 0. Okay, f of x. Okay, f of x is 2x. Oh, good, right? So everything disappear. All right, so the f of x is 2x, and that's easy, right? F of y, that means is 4y. Boom, now it disappeared. F of the z, so do you see how easy that is? F of the z is 2z's, right? Okay, so now I need to find the f of x, the partial. That means it's rho z, rho x. Okay, so it's a negative f of x, so it's a negative 2x, and what is 2 what? And 2z's, right? Okay, so negative 2x and 2z. Now I need to plug in the point 2, negative 1, and 1. So x equal to 2. So it's negative 4. So this is 2. So it's negative 2. So the partial for the f of x is equal to negative 2. Then I do the same way. The f of y will be equal to negative 4y over 2z. So this will be equal to the negative 2, the y over z. Then I plug in the point. So it's 2, negative 1, 1. So it will be negative 2, y is negative 1, 1. So what is that? It's 2. Well, it's easy, right? Okay, so finally, my tangent plane. So my tangent plane. So what is my tangent plane will be? Z minus 1. So it's z minus 1 is equal to f of x is negative 2 to the x minus 2, correct? Then plus f of y, so it's 2y plus 1, right? Okay, so if you simplify it, then we can get this is 2x minus 2y plus z equal to 7. So this is the tangent plane. Okay, and let's see it. So as you can see, this section, the chain rule section, is a very easy section. See here. So the key things to take out from here is try to, when you use the chain rule, so if depends on how many variables here. So basically we introduce a new notations, right? So make sure you know the differences between the rho and the d, right? The rho 0x, dz, dx. That means if you see the rho 0x, then you know z is a function more than one variables here, right? All right, and the next things here we say is important to remember, like it's used in implicit differentiations. So this is a short, kind of like a shortcut of formulas, right? So it's a little easier than what we learned in the calculus 1. All right, that's it. So it's easy sections, and I hope you learn something new things to do the implicit differentiation, and let's see it. And you have a good day, and I'm looking forward to talk to you in our next videos here. Okay, bye-bye.